On the SAT, algebraic expressions problems test whether you can simplify, factor, and manipulate expressions quickly without getting stuck in long steps. Let us break it down. An algebraic expression is a mathematical phrase that uses variables, numbers, and operators to represent a relationship between quantities. For example, if there are 12 chocolates and 8 ice creams, and each chocolate costs X dollars and an ice cream costs Y dollars, the expression for the total cost would be 12x plus 8y. Here, we are translating word by word a statement in English into a mathematical expression. So in this expression, 12 is called the constant and x is the variable. So in 12x would be the total cost of the chocolates, and 8y would similarly give us the total cost of the ice creams. When a question asks to write one variable in terms of another, so we isolate one variable and transfer everything to the other side. To get that, sometimes we cross multiply when there are algebraic fractions present. And just like we add, subtract, multiply, and divide numbers, we can add, subtract, multiply, and divide algebraic expressions. Sometimes there could be exponents, so we have to apply the properties of exponents to solve for the required variable. For example, consider an algebraic expression in fraction form where you have the variables in the denominators. So here we cross multiply first, and then we get 4 times y minus 2 equals 8 times x plus 1. We simplify further and we just keep y on the left hand side and transfer everything to the right hand side. So first we will add 8 on both sides so that the 8s gets cancelled on the left hand side, and then we divide by 4 to isolate y and get the expression. The next method is by comparing similar terms. This is also an important strategy in solving equations. Now, the question is going to ask for some missing constants in an equation. So we're not going to solve anything, but we are going to match the similar terms on both sides. So you could see an expression on the LHS and also an expression on the right-hand side. So first, we need to expand on either side, no transferring variables from one side to other side. And then we simply match the coefficients of the similar terms. For example, consider this equation with some expressions on the left-hand side and an expression on the right-hand side. Now, to find the values of the missing constants, we are going to match the similar terms. First, we are going to expand on the left-hand side, and we are going to get a similar expression as on the right-hand side. Now, compare similar terms. So, x square terms, and then the x terms, and then the constants. Now, by matching the coefficients, 5a must be equal to 15, so a will be 3. 10 plus 7a must be equal to b. So that will give us b as 31, and then the constant c must be 14. When you come across a higher order algebraic expression or some lengthy expression, now solving becomes a challenge. So then you could simply plug in and save your time. Now, the question will generally ask for an equivalent expression in the options. So you could plug in some easy values to quickly get the answer. For that, first we need to observe the given expressions and identify all the variables. Then think of some easy values like 0, 1, and -1 to plug in the corresponding variable. Now, we are not going to plug in values where the equation becomes undefined. So we need to think of some other easy values and plug in different numbers for different variables so that you won't get confused. Now, use those values and look for a match in the options. Now, we could use the Desmos also to calculate for values. For example, if it is given that x plus 5 equals t, and we need to find 2x plus 9. So instead of solving or rewriting the equation, we could simply plug in x equal to 1, which gives us the value of t as 6. Now 2x plus 9 for x equal to 1 would be 11. Now we need to find 11 in the options by plugging t equals 6. So now we could go through the process of elimination. So A not give us the answer. B also is not giving the answer as 11 for t equals 6. C also is not the right option. So D will be our answer, where we get the value as 11. Now, here we have a tricky SAT question where it tries to confuse us between the variables and the constants. In this question, the N indicates the number of nickels, which will be the variable, and the value of each nickel would be the constant. So each nickel is 5 cents. So N nickels would be a total of 5 N cents, where the value of each nickel is the constant and the number of nickels N is the variable. Similarly, a dime is 10 cents. So D number of dimes would be 10 D cents. Again, 10 is the constant, the value of each dime, and D is the number of dimes, which would be our variable. And the total of 5N and 10D would be C cents. Hence, the equation is 5N plus 10D equals C. All are in cents. So the tips for solving algebraic expressions are go always word by word in the same order as it is given in the equation. So just like the earlier example, do not get confused between the variables and the constants. Just like we add, subtract, multiply, and divide on either side of an equation, sometimes we could also do reciprocal, which would make us solve the question easily. And whenever you are substituting a value in place of a variable, please hold it in brackets, which are very important. With and without the brackets, the expressions would lead to different answers. So please be careful.